Hello everyone, today let's solve the problem 846 hand of states, right? So let's see what the question states here. See, just give me a second here. Yeah, Alice has a hand of cards that is represented by the integer array hand. See here, again Alice has a hand of cards represented by an integer array hand, right? So see here 1 2 3 6 2, these things, right? So can the cards be rearranged into the groups of size, group size? So group size we have been given 3, so this has to be rearranged in the group size format, meaning 3 3 3, right? So 3 cards basically in simple terms, right? So here see group size we have 3, and they have asked us whether can the cards be rearranged into the group size such that each group contains group size consecutive numbers. So this is the criteria, this is the twist basically, right? So can the cards be rearranged into the group size such that each group size contains group size consecutive numbers? Can it be done? So that's what they have asked us to do. So we have to return true if it is possible, right? Otherwise we have to return false. If it is not possible, we have to return false, right? See here 1 2 3 6 2 3 4 7 8 we have. So this is true because Alice's hand can be rearranged as 1 2 3 2 3 4 and 6 7 8. This is fine, right? Yeah, this each group contains group size consecutive numbers here, right? So 1 2 3 starting from 1 2 3, this one 2 3 4, this is fine, and this starts from 6 6 7 8, right? So this is true. So now the second example we have been given 1 2 3 4 5, group size we have 4, right? So this will be false because Alice's hand cannot be rearranged into the groups of 4. So we cannot rearrange, man. See here, we cannot rearrange, so one element will be left at any cost, right? So this one we cannot rearrange, so in this case we have to return false, right? So this is fine. Now as they have given us wonderful examples just for the sake of understanding, now we have the idea on the question as well. Now let's do one thing, let's quickly discuss the this one approach followed by the complexities, and then let's write the code, right? As usual, let's discuss the complexities first. First thing is we will be going with the greedy approach, right? So just remember one thing, we will be going with the greedy approach, right? So first let's consider the same first example. I'll just explain this one, so I can just try to implement the same thing in the form of code. Same thing, right? You can just try to implement the same thing, or yeah, implement the same for the example 2. So you have to get false in this case, right? So let's see for the first example first. So hand we have this one 1 2 3 6 2 3 as well as 4 7 8. Group size we have 3. First let's count the frequencies, right? So the first step will be for counting the we will be counting the frequencies. So this will be 1 is present how many times? Only once. You can just see the array, this array we are considering, man. Don't get confused, first example. And what about 2? 2 is present 2 times, or the twice, right? So 2, frequency 2, and 3 is also present twice here, or the 2 times. So 3, this one is also 2. Frequency of 3 is also 2. You can see here 3 3, 2 is also present twice, right? So next 4 is present only once, right? 4 is present only once, so frequency of 4 is 1, and 5 is not present. Let's 5 is not present in the array at all. So 6, let's go with the 6. 6 is present once, 7 is present once, and 8 is also present once. So 6 is once present once, 7 is present once, and 8 is present once. So this is fine. 8 is also present once. So 1 2 1 is present once, 1 4 6 7 8 is present once, and what about this one? 2 and 3 is present twice in the array, right? So this is fine. Now after counting the frequency of each number that is present in the array, we will always start from the smallest available card, right? So we'll be going with a greedy choice, right? Smallest will be 1 with a count 1, right? So just remember this, right? So we must form one group that is starting at 1, nothing but we have to remove 1 each of 1 2 3 counts to become 2, this one, then count becomes what? So here this one 2, we have to remove once, this one, right? 2 ones, 3 ones, 4 ones, this one is also fine, and 6, 7, 8 also ones. 6, 7, 8 also ones. So what am I speaking here? Again I'll tell this point. Let's discuss this point again. So we have to always start from the smallest available card, right? So we are going with a greedy choice right here. So this one we are going with a greedy choice. So we have to always start from the smallest available card. So what are the so what is the smallest here? This one. So we will be going with the smallest equals 1 with the count 1, right? Smallest among all the numbers is 1 here. Smallest is 1 among the count 1. So we must form one group that is starting at 1, right? So let's remove one each of 1, 2, 3. Let's remove one each of 1, 2, 3 here, right? So we will be removing this one once, this one, right? So this is present twice, we'll be removing 1 here. So 2 ones, 3 ones, 4 ones, 2, 3, 4, 6, 7, 8, all this one once, right? So next smallest is 2, right? So first smallest was 1, we considered this one, we got this one. Next smallest is 2 here, right? So when we consider 2 with the count 1, so we are left with 2 with the count 1. We have already considered 2 with the count 1 for this one, right? So now we are left with only 2 with the count 1, right? So 2 with the count 1 we are considering now this time, right? So we can form the group 2, 3, 4 right? So first for this one, what is the group that we formed? Basically from this we formed 1, 2, 3. 1, 2, 3 was the group that we formed from this, right? By removing the frequency, this one, frequency of 2 and 3, right? Once, by considering frequency of 2 and 3 only once, or the count 2 exactly once. So here also we are considering the 2 with the count once, right? So this will, we can just form the group 2, 3, 4. So we have to remove them, right? So 2, 3, 4 we have to remove them. So then we are left with counts here, this one, what do we call? 6 ones. We are left with only 6 ones, 7 ones, meaning 7 that has the count 1 or the frequency 1, and 8 which has the frequency 1 here. Simple, very simple. Same thing we will be doing for the third, this one as well, right? So third step as well. Next smallest is 6. Among the 6, 7 and 8 we have the smallest 6 here, right? So next smallest is so 1 we have already considered. 1 is for this one smallest. Next smallest was 2 because we were left with these things, right? 2 again, frequency was 2. One count of 2 we considered and one more 2 was present. So 2 with the frequency or the count 1 was present. So again the smallest was 2, and then we formed the group 2, 3, 4 here. First we were able to form the group 1, 2, 3. Second we were able to form the group 2, 3, 4. Now we are left with the count 6 ones, 7 ones and 8 ones. So 6 is the smallest number among 6, 7 and 8. So we will be going with 6 here. First we'll be considering 6 with a count 1. So frequency we have 1, right? So 6 with count 1. So we are able to form the group 6, 7 and 8, right? So now we are able to form the group 6, 7 and 8, right? So we will be removing the frequency. So now the map is left empty, right? So now the left map will be left empty because we don't have further elements, right? So we have used all, right? So all the cards are placed in the consecutive groups of size 3, right? So see here, we have got 1, 2, 3, 2, 3, 4, this one and 6, 7, 8. So we have got, let me write it over here. So first group that was formed was 1, 2, 3, and the second group that was formed was 2, 3, 4, this one, and the last group that we were able to form was from this one here, this one, 6, 7, 8. 6, 7, 8, right? So now all the cards are placed into the consecutive groups of size 3. See here, size 3, consecutive groups of size 3, 3, 3, right? So this is fine. So in this case we have to return true, right? So let's return true here. Let me write somewhere over here true, this one. So the output that we got here is true, which is equivalent to the output that they have mentioned for the this one, example 1 within the question. So our approach works absolutely correct, right? So our approach works absolutely correct in this case. Now as we are completely familiar with the approach, let's quickly discuss the complexities. right? So what will be the time complexity here? The time complexity would be because of n log n, right? So the time complexity would be because of n log n, right? So why it is because of n log n, not just n here? So n log m, sorry, not n log m, this one, n log m here. So this can be commonly stated as n log n as well. So n is nothing but the hand length. N is nothing but the hand length. So this one, the length of the hand array they have mentioned here, right? So n is nothing but the hand length. So this one, for this particular example, it would be 1 2 3 4 5 6 7 8 9 9, right? So here n would be length of the hand, and m is nothing but the number of distinct card values, because each operation on the tree map is big of log m. We know that, right? So we are processing each card and counting a constant number of times. So overall time complexity would lead to big of m log m. So what would be the space complexity here? The space complexity would lead to big of m, right? So why it would be big of m? Because m is nothing but the distinct card values, right? So that we are making use of to store the frequencies, making use of it to store the frequencies. So m is the number of distinct card values that is less than or equal to n used to store the frequencies, right? So overall space complexity would lead to big of m, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of this one, n log m and big of m respectively, right? So now, as we are completely familiar with the approach and the complexities part, we are good to write the code. Let's start writing the code, right? So now first step would be here, this one, what do we call so if the total cost is not divisible by the group size, so it is impossible, right? So in that case we have to return false. So here it would be see here the same thing, group size is 4 here, and hand we have only 5 elements, right? So if total cards is not divisible by group size 4, this one 5 divisible by 4, no, we'll be getting in the decimal points, right? So here in that case this is not possible, we can directly write this one false, right? So this is the base case, right? So let's go with here length of the hand. So I'll just go with a hand length modulo group size. So if it is not equal to 0, then we have to return false, right? So this is fine, man. Next step is we have to count the frequency of each card value using the sorted map, nothing but we'll be making use of the tree map, I won't lie. So I'll just go with tree map here. So this one will be integer comma integer, this is fine. So this one will be frequency equals new tree map, this is fine. Now this is fine, man. Yep. So let's go with a for loop here, simple for loop. So let's consider for each card in the hand. So I'll just go with for here int v in the hand. So within the for loop, so we have to increment its count, right? So I'll just go with frequency dot put operation that is provided by the hash map. So I'll just go with v comma frequency, again I'll just make use of the this one get operation that is provided by the hash map, or let's go with a get or default. So let me go with or default. So this one will be v comma 0 this one will be plus 1, this is fine. So we are incrementing its count, so this is fine, man. Now let's go with a simple while loop. So while while there are still cards to arrange, right? So I'll just go with while not of frequency dot is empty. So within the while loop, let's go with a int here. So let's go with the smallest available card. So I'll just go with start here. Let me assign this one to the frequency, but let me go with the first key. So we are we went with the smallest every time, right? First we considered 1, then we considered 2, then for the third one we considered 6 smallest that is present in the sorted map basically. So this one will be first key. First key, so that is provided by the hash map, right? Now we have to go with how many group must start or use, right? So we have to go with how many groups must start or use this smallest card, right? So in our case we got 3, right? So this is fine. So how can we articulate that one in the form of code? So I can just make use of get, I believe. So this one will be int need equals frequency dot get of, let me pass start here. This is fine. This is fine, man. So the next step is, let's try to form need groups starting at the start, covering start to start plus group size minus 1. So let me go with simple for loop here. So this one will be int offset. So this one will be 0. So this one will be offset. So less than group size. This is also fine. Let me increment offset here. So within this for loop, so let me initialize key to start plus offset. So this is fine. So basically this is nothing but the current consecutive card value, right? So next we have to go with the how many of this particular card we currently have. That one also we have to consider, right? So let me go with here integer. I'll make use of variable name have here. This one let me give frequency dot get of, let me pass key here. This is fine. So we have to go with the missing required consecutive card, right? So if the card is missing, meaning a consecutive card is missing, then it's a fail. Then we have to return false in that case. And also one more condition. So if if we don't have enough copies to satisfy need groups, then also we have to return false. So these two conditions, let's write here. So if have equals null, then we have to return false in that case. The next one is if have less than end, then we have to return false in that case. This is also fine. Now let's subtract need used copies. We have to remove key if 0 left, right, in simple terms. So I'll just go with if have equals need, then frequency dot remove. So this one, let me pass key here. This is fine. And else I'll just go with frequency dot put this one key comma have minus new. So this is fine. Now we are almost done, man. So we are left with only one thing, meaning if all cards are successfully grouped. In our case we were able to group the cards, right? All the cards successfully. If all cards are successfully grouped, then we have to return true in this case, right? So I'll just go with return true. So we are done with the code. This is it for the code. So let me format the code once and let me hit the run button. So we have this one frequency dot get, right? So I have mentioned comma here instead of dot. So let me run this one. We have some more errors. Line number 11. Now if I try to run, this has to give us, yeah, if have less than end, cannot find the symbol end. So end, didn't I mention end? So start I have given, need I have given. Just give me a second here. So it is not the end, right? So we are going with the need bit. So I can clearly see here all the test cases are getting passed, means the code works absolutely correct in this case, right? So whatever the code that we have written works absolutely correct for all the test cases, right? For now I think this is it. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.